All right, for the video, we're just recapping Wednesday's lecture, so the bench press example. All right, so complete two sets. If we're starting the set counting at 1, what do we put in the condition to make sure this only runs 2 times? Yeah, set is less than or equal to 2, because the first time we'll print begin set 1, second time we'll print begin set 2, and then when set is equal to 3, that won't be less than or equal to 2. What's the other thing we need at the end of the loop? All right, what happens if we put this set equals set plus 1 line? What happens if we put that at the beginning of the while loop? Yeah, so the loop will still run 2 times because we didn't change the condition, but what we output will be different. It'll say begin set 2 and set 2, and then it'll say begin set 3 and set 3. So it'll still run twice, but the count is going to be 2 and 3, which isn't what we want in our case. So do people understand why we need to put that at the end of the loop? Yep. Okay. Okay. And then you'll notice in here, we're saying every time we do a set, we're going to complete 3 reps. And so every time you do something multiple times inside of another one, that's your indication that we'll have a nested loop. So let's think about how we'd write this code for the complete 3 reps. If we start the rep at 1, what do we want to put as our condition? Okay, well rep is less than or equal to 3, and then what do we put at the end? Yeah. How about if we had rep counting from 0? What if we had int rep equals 0? Then what would we put as our condition so that it still runs 3 times? Yeah, less than 3 or less than or equal to 2. That way we'd have 0, 1, 2. I'd encourage you when you come up with your condition to actually count through and see how many times is your loop going to run, and is that expected for what you want. We call these, people call it different things. Generally, the way I was taught it was as border cases. So these off by 1 errors. A lot of times when you do your condition, as long as you generally get the idea, what you have to be careful of is off by 1 errors. So oftentimes, even in the midterm example, when people were doing less than 99 instead of less than or equal to 99, that's an off by 1 error because your loop ran 1 less time than it was supposed to. And the way you can prevent those errors from happening is by actually counting through the loop. Okay. Any questions here on how we do the compute 3 reps? Okay. So putting them together now, this was the code for complete 2 sets. All we're going to do is, the next slide is going to have a lot of code, but it's literally just going to take this code that we wrote here and putting it in the complete 3 reps. So we go to the next one, and it's the same thing. We just, instead of the comment complete 3 reps, now we actually put in the code. So we start the rep at 1, and we have it less than or equal to 3. Yep. All right. Any questions here? How many times does this cout statement run? This one at the top. Okay, I heard 1, 2, and 3. Twice. Okay. Why does it run twice? Yeah, so this condition is set less than or equal to 2. So this will run begin set 1, then it'll print begin set 2, and then it'll stop. Right? So this outer one is going to run twice. How many times is this cout statement going to run, this complete rep? 6. Why does it run 6 times? Yes, 3. That's a good way to think about it, right? 3 times per set. So this inner while loop is going to run 3 times every time this outer while loop runs. So 2 times for the outer one times 3 for the inner one gives you 6. And we saw that here. So the begin set 1 and begin set 2, that happens twice. But the complete rep, that comes 1, 2, 3, 4, 5, 6 times. Yep. All right. And so final recap slide. 2 things to call out. When you actually write your code, especially for the Wordle project where you're going to have 3 nested statements, make sure you line up the curly braces before you actually start coding. So you'll notice this W in while is lined up with this curly brace. This W in while is lined up with this curly brace. So we know once condition 2 is false, we can just come to this matching curly brace and any code after that will run. Right? And then the other thing I'll call out, the code in the outer loop will run x times. The code in the inner while loop will run x times y times. What happens if we had another while loop inside of here that ran z times maybe? How many times would the code in there run?
It would be x times y times z.
Yeah. So every time you have a nested loop, you multiply by how many times it would run. So if we had 3 nested while loops, it would be x times y times z runtime. Okay. Any questions on nested while loops? The lab, I think, was decently hard. I think people who came into lab were able to finish it in lab, and I think it would have taken people a lot longer if they hadn't come into lab. So if you didn't come for the Wednesday lab, make sure you come in today at 4, or you come in for Monday's lab at 5. Yep. The trick with nested while loops, like once you get it, it's generally pretty clear. It's just hard to think of the solution with nested while loops, and that's what the lab really tries to make you practice. Okay, so we're gonna do game musical chairs. Hopefully most of you have played it or heard of it, but we're gonna demo it real quick. So can I get 3 volunteers for musical chairs? Who wants to move around a little bit? All right, 1, Omar. Kadir, 2, 1 more. 1 more volunteer. Yeah, Robert. All right, Robert, can you bring up your chairs? We'll do it at the front here. Morning games got heated. I felt like the TV was gonna break with people crashing into it. So we'll have 2 chairs. So notice we have 3 players, but just 2 chairs. We'll line them up here, back to back. Okay. Yeah, we'll do it like this. Okay. So with musical chairs, while the music is running, note that they keep walking around. Notice how I use the word while to describe that. What happens when the music stops? What are they supposed to do? They're supposed to sit down. 1 person's going to get eliminated. All right. Robert, out of there. Sorry. So Robert's out. We remove 1 of the chairs. Here you go. So think about this, even in terms of code, what's happening every round, what's happening to the chairs, what's happening to the people walking around. All right, I'm going to close my eyes so I won't be biased when I pause it. Oh, Omar swoops in. I think he's got more on. All right, so Omar with the win there. Cool. Thank you guys for volunteering. Appreciate it. You can take the chair back. Okay. So in groups, I'm going to have you all write the pseudocode for musical chairs. And then I'm going to take your pseudocode and we're going to test it out with live demonstrations. All right? So we'll have you 4 grouped together here. Your pseudocode should have 2 while loops. Try to make sure it looks kind of like the structure of code, but you can give summaries. So, you know, we might not know how to code music playing, but you can just write down music playing, right? All right, Jonah, I'll have you join like this group of 4 here. Yeah. Okay. I'll have you scheduled to meet for today at some point. We'll take care of that at the end of class. All right, and then we'll have you 4 go together here. So again, you can just give summaries. You don't know how to. You don't need to know how to code the music, but you can just say like while the music is playing, you do something, right? So think about what your nested loops are going to be. And think about what goes in the outer loop and what goes in the inner loop.
Chairs equals chairs.
Also, sorry, start your pseudocode with like asking how many players. So you'll know how many players are playing the game, and then you can use that to figure out how many chairs should be starting the game.
Honestly, I don't know. I think the outer loop is going to have to do with the chairs because that's going to be done even while the music is in chairs equal to players, or chairs equal to players minus one. Right. Got any thoughts?
Players for how many players, and I think that's chair will be players number chair will be
you can set somebody to like Or I guess originally we had one more the players and chairs. And then we should be like minus one player. So what we could probably do is like long playing and players is greater than
we're just trying to figure out players is equal to players minus one chairs
and
equals share.
And then like random players and chairs.
That's the algorithm.
Well, one
Number of chairs.
You used to go,
So it's like,
yeah, I think it's good.
What do you mean? I don't know if it's gonna be that.
wow.
You know, I mean, you could just have.
Whatever player number is.
Because most of which is
Like 10 player. Yeah.
I don't know. Something regular player.
Play what?
you could play right
Share.
Because we have players.
Right.
And that's
So like,
so that means every time we go.
one
So now we need to add the
share.
Well, you
Then
don't want to add that because the wild is
number
basically
of
what we just playing. So the stops is like,
Yeah.
So it'd be like, say, are there like some players and then one less share than the players? Music playing players greater than one. Players walking. Music.
We'll give groups like 2 more minutes, hearing some really good conversations.
Player eliminated.
somehow we'll have to.
And then like outside of this would be like
After this stops, you do players minus
Morehouse had good Lecture. So a line, yeah, a whole lot of line.
I just made like one change to the chair tactics, saying that it should go minus one. Because I programmed how many chairs there are. That's what they think they will all happen. Is that here? That last one is the guy. So it would be like, it's not good, but.
We're trying to, I know, maybe kind of give you a time. Okay. I see two groups did it pretty similarly, so we'll try that one first. Can I get 3 different volunteers, please? 3 different volunteers. Who wants to go? Cool. Thank you, Jamali. 2 more. 2 more volunteers. Cool. Thank you, Troy. 1 more. 1 more volunteer. 1 more, 1 more. People don't want to play musical chairs? Justin? All right. Okay. So we're just going to go how the pseudocode goes. So this one says, ask how many players. We have 3 players. They said chairs is equal to amount of players minus 1. So 3 minus 1 is 2. We got that set up. And their first while loop, it says, while the music is playing. So we'll play the music. And while the music is playing, they say walk around. Okay. And then they said, all right. Okay, so a lot of groups here, they said while the music stops. So the music stops. All right. So while the music stops, hold up before we do it. So while the music stops, 1 player is eliminated. Player is equal to chair minus 1. Player is equal to chair minus 1. So it would be more the chair is equal to chair minus 1 because we want to get rid of a chair. And then the other group that did it similarly, they did. Okay. So this other group did players equal to player minus 1, but then didn't change out the chairs. So we're going to leave both chairs there, and we'll work with the pseudocode. So nothing about the chairs being removed. And so now, while chair is not less than or equal to 0, it's not. Then we keep going. So we would keep playing here. And then while the music stops, no competition, right? So we would have, this is a case where you would want to make sure that you actually reduce the number of chairs each time. One thing that I note here is like, people are saying while the music is not playing. Why do we not need to, like, there's kind of a loop for while the music is playing and then another loop for while music is not playing. Why do we not need both of those cases?
Because if the music isn't playing, it's playing. And then if it's playing, it's not playing.
Yeah, this is almost setting it up like an if-else statement, whereas it's really just like while the music is playing, it's walk around. And then once that while loop is over, we know the music isn't playing anymore. And so we can just write the code that's like remove a player, remove a chair. We don't have to create a separate while loop for that, right? Yeah. All right, cool. The other one, can I get, there's one paper that I was missing back here, right? Let me grab this. So a lot of people put while the music is playing as the outer loop. And I'm trying to, in reality, it's kind of the inner loop. Like what is kind of the outer condition that's happening each round? What are we trying to check there?
The music's playing.
Yeah, so in each round, we check if the music is playing, and they walk around. But that's just for one round. Outside of that, we could have like 3 rounds if there's 4 players. So what's kind of like the outer condition that we would want? How do we make sure that we don't keep playing forever?
The amount of players equals 0.
Yeah.
Less than or equals 0.
Yeah, so I'm trying to, yeah, so while, yeah, so essentially like the outer loop, so the one we have here, ask how many players, chairs is equal to players minus 1. The outer condition is like while chairs is greater than or equal to 1. Then inside of that, that's like a round, while chairs is greater than or equal to 1. Inside of that, we can then check while music is playing. Then we walk around and we do stuff. So like, sorry, you two can sit back down, my bad. So like if we were to like write out the pseudocode, it would be like, ask how many players, so like number of chairs, what is number of chairs equal to? So it'll be based on the players, right? So like let's say we had a variable for num players.
Players minus 1.
Yeah, so it'd be like num players minus 1. And then for what condition do we want the game to keep going?
While none plays by less than 2. Or greater than 1.
Yeah, so you can either do it with chairs or players based on what you want, but we can do like while num players is greater than 1. Because if we just had 1 player remaining, we know that that person is 1, right? So that's kind of what goes in our outer loop, because then we can congratulate the last player remaining. Because at this point, we know that there's only 1 player left, and so we'd congratulate them. So here, while num players is greater than 1, so this is kind of like we're going to play each round, play a round. So what goes on in a round of musical chairs? Okay, and in what condition do we want to walk around? Yeah, so in here we would say like while music is playing. Oops. While the music is playing, then we can walk around, right? And then at this point, what do we know at this point is true? When we're inside the outer loop, but we're outside the inner one. Sorry, that was kind of confusing to say. So like this inner while loop is complete, but we're still in the outer one. What do we know is true?
Number of players is greater than 1.
Yep, we know number of players is greater than 1. And what else do we know?
None plays not 1.
So that's what we'll do, but what condition do we know is true or false?
Music isn't playing
Yeah, why do we know the music isn't playing at this point?
because
Yeah, if the music was still playing, we would have still been walking around, right? So at this point, if you think about it, like when the players are walking around, the music stops. It's not like they're doing an extra if check, like, oh, is the music still playing? They just know because they're out of that while loop, like, I can just sit down. So at this point, like, we know the music isn't playing. So it would just be like players sit down and the one without a chair gets eliminated, right? And so then we would like decrease num players. What would we put here? Yep. Something like that. All right. I couldn't like fully properly explain it in the example of like the other thing that that I saw a lot of in the pseudocode was something like in the outer while loop, like while music is playing, and then people put another one in here while music is not playing. Sit down, right? And in here people are saying like walk around. Do people understand why this isn't super ideal? Like it's forcing us to do like extra while loops that we don't need because they're checking like opposite things. And then like in here, like people were putting like a third while loop in here that was like while num players is greater than 1. Then they're saying like, or like while it's like not less than 1, like endgame. Like it doesn't really fit the flow of how musical chairs actually works, right? In musical chairs, we think of it like this, where while there's still players remaining, we do another round, and in a round, we play the music, and we walk, and then we sit. Yep. Okay. Cool. Any questions on that exercise? On the pseudocode? Okay. So now if we were to actually to code this out, so we'll start with the first part, like doing each round. So we kind of said it already. We'll do our code in terms of num chairs. So what is num chairs equal to? Yep. Sorry, I realized I had it on the slide. Yeah, so num chairs is equal to num players minus 1. And then in terms of num chairs, what's the condition that we want?
One num chairs is greater than 0.
Yeah, so while num chairs is greater than 0. Because if there's still 1 chair, we still want to play for the final round. So it's while it's greater than 0, and then what happens to num chairs at the end? Someone who hasn't answered yet.
Num chairs equal to num chairs minus 1.
Yeah, cool. So everyone good on this part? And then for the next part, if we want to actually play the music for a certain amount of time, you don't have to memorize this. Like we'll learn more about it later, but C++ has a function called rand that gives you a random number. Does anyone remember what this symbol is, the percent sign? Modulo. So if we modulo any number by 30, so that's like dividing it by 30 and getting the remainder is always going to be between 0 and 30. Right? If you had like 30 divided by 30, that's remainder 0. 31 divided by 30, remainder 1. 59, remainder 30, that's remainder of 29. 60, remainder 30 is just 0. So this will give us any number, this line will give us any number between 1 and 30. And then I'm just saying like, we'll increase the time by 1 second for every second that passes. And while the time is less than the random time, keep playing the music. So we would have like some C++ library that lets us play an audio file that we would put in the while loop. And we keep playing that music until the random time has elapsed. Yep. Any questions here? All right. I'm hoping the takeaway is like, if you start to code all this and then you realize you have a mistake, it can be very hard to fix. But with your pseudocode, you can like do a live demonstration, or you can do the example in your head and make sure your pseudocode works before you actually code it. And it's much easier to fix pseudocode than it is to go back and fix actual code. And so that's the other big takeaway I want you to have here. And part of why for the Wordle project, that last section 9, I ask you to actually write the pseudocode before you start coding, is that I know like I've been seeing the comments that the TAs have left on our like shared spreadsheet, and they're saying like people mostly got it, but just like 1 or 2 conditions here, and it's easier to like fix that when you're just talking about it in the doc than to go through your code and try to fix it. So hopefully people have been finding the appointments useful. I know a lot of people have appointments today. Please make sure you show up on time. Like 20 minutes isn't enough time to go over the starter doc, so we're already trying to squeeze it in. And so people are coming like 6 or 7 minutes late. The point of the appointment is to help you, like make sure that you're ready to code. You're gonna get the 20 points if you attempted the doc. So it's really just to make sure that you feel confident going into the weekend and next week with the coding. So try to show up right on time. You should have gotten an email with the appointment link. If you didn't, come and talk to me after class and we can find it, or I can have the TA send it to you personally. Yep. All right, everyone good here? Okay, final part. I'll just spend like 3 or 4 minutes on this. Wordle output. So people have been asking what should the output look like. It's up to you. So one way you can do it is you can just mark the letter. So you can say like if the answer was like ASK, it can be like A is green, S is yellow, K is red. And with that, you just like see out the letter and then just the string green, yellow, or red. Yep. This is just like printing how we would normally print like anything else that we've done in this class. Yep. So does this make sense for how people would do that?
Yeah.
Okay. And then this one, if you want to actually color the letter, I realized I'd accidentally left like some bad scaffolding code in the doc. So when you open the Wordle doc, I'd encourage you to just like delete everything and start from scratch because there's some stuff in there that you don't actually need. The only stuff you need are these 4 variables if you want to actually color the text. And so you can look at the slide later, and I'll also add it to the Wordle doc. But you just need to add these 4 lines to get the red, green, yellow colors and reset. And the way you would use this is you would see out whatever color you want, then the letter, and then the reset variable. And what this is doing is like this variable red is saying like anything after that string is going to be printed as red in the console. So we're saying like change the console color to red, then print the letter, and then change the console color back to the default. And so here I just printed out red, green, yellow, but in your case you would do like the if it's green, print it out in green, if it's yellow, print it out in yellow, if it's red, print it out in red, right? Okay, and if you wanted, you could do them on the same line. So instead of putting the end L, you can just print out the whole word on the same line. It's up to you. There's not gonna be an autograder for this Wordle project. Instead, next week, you're gonna meet with the Googler TAs again. I'll share the rubric with you all beforehand so you know what you'll be graded on. But it's essentially going to be graded on style. So do you put comments in your code? Do you choose good variable names? Do you indent properly? And one thing I want to say on variable names, when I've been looking at people's code, for variables like the number of guesses, some people are just putting like the name guess. And that's very confusing to read because when people think of guess, they think of the word like a string guess. So if you're using like the name guess to count the number of guesses, that's actually not a good name. And something like num guesses would be better. Generally, if you're doing some sort of count, the default is to put like the word num in front of it. So like num chairs, num players, num guesses. Those are all very clear that we're talking about an int. Whereas something just like guess, that's more the default assumption is that's a string, right? So that kind of stuff, that'll be like worth 10 points. There'll be a part on code comprehension. So we want to make sure that people aren't just like copying other people's code and passing it off as their own. So the TAs will ask you to actually like walk through their code and they'll ask you questions like, how many times is this line of code going to run? So do you actually understand nested while loops? Why did you use this condition here? So just, if you did the code yourself, you'll get those points, right? Because you'll understand what's going on. Code correctness and testing. So for testing, we want you, because there's no autograder, you have to actually test. So what are some things you want to test? Like you want to make sure that the game stops after 6 tries if the user hasn't gotten it right. You want to make sure that the game correctly prints out red, green, or yellow, right? So these are the kind of things that as you finish coding, you should be testing your own code. And again, I'll release the formal rubric next week before you meet with the Googlers on Wednesday through Friday. Yep. All right, any questions on anything related to Wordle? Everyone good? Everyone who's like had their appointment feel good about coding? They know how they're gonna attack it? Cool. In my mind, if the starter doc conversation went well and you really understand, especially if you understand the pseudocode, the coding realistically I think will take about an hour. It'll really just be about like 50 lines of code total. So about the length of a homework. I didn't assign any homework for this week so that people can work on Wordle. Right? Okay. Cool. So again, what's due? Appointment today. I know the Googler TA appointments are fully booked, so if you don't have an appointment booked, come up and see me after class so we can figure out a time to get you your points. Test makeup due tonight. Wordle code will be due Wednesday, October 12th. There's also lab. So Wednesday lab attendance was a little bit short. Maybe people didn't realize we had lab this week. Lab is on nested loops. The best way to practice loops is to actually do it yourself. So make sure you come into lab. It is a hard lab, but we will provide support. And then final thing I'll say is if you didn't do this participation grade on Wednesday already, like we still have some time. So like pull out your laptop. It's just 3 questions. I need to submit midterm grades this weekend. So I'll be using your participation grade for that. Cool. Any questions on anything? Alrighty. We'll end a little bit early. Thanks all.